Well, so lecture 10, so organic farming and climate change as a continuing. So, here we will be discussing the organic farming as a key role in climate change mitigations or how we can mitigate the climate change through organic farming. So, we'll first we will learn about the adaptations and mitigations in agricultural productions, then we will move smoothly to organic farming as climate change mitigations. If you talk about the adaptations and mitigations, as you say the climate change that has impact. That means, if the climate change including the climate variability. So, this has exposure, then initial impacts or the effects maybe see the agricultural productions. So, there is a impact of climate change, then every crop has autonomous adaptations. So, the crop also try to adapt to the rising temperatures, and sometimes the farmers during the practice agricultural practices, so they also become adaptive to the usual climate change, that is a autonomous adaptations, then there is a residual or the net impact of climate change. So, one is the other side the impacts, then there is a vulnerability. Vulnerability, if you go for the economic assessment, that means, so if there is impact, the adverse effect on the agricultural productions, then how vulnerable is your the food production to climate change. So, it depends upon like examples of in a particular location. So, the farmers are growing mainly rice crops. So, more area under rice, and also the some farmers grow wheat crops, and wheat is very less. Suppose 90% area is diverted for rice crops and 10% for wheat crops. The effect is much more on wheat as compared to rice. If you talk, then you talk about vulnerability, then that area may be, even though the impact is less on rice, but there is impact adverse effect, but the high area under rice acre is higher as compared to wheat. So, the farmers will be highly vulnerable to climate change. So, the vulnerability assessments through climate change, once we have, then policy makers make the planned adaptations through planned adaptations the impact can be nullified, can be reduced, the adverse impact of climate change on the rice production or the food grain production can be reduced through the planned adaptations. So, in addition to the adaptations, so there is mitigations. Mitigation means, so our activity, the management practices should be such that, so there should be less emission of greenhouse gases to the atmosphere. So, that is known as the mitigations. So, the adaptations and mitigations, they should go hand on hand. There should be adaptive mechanisms, so that it should minimize the impact of climate change. At the same time, there should be mitigation strategy, so that we do not allow the climate to change at a faster rate. So, that means, so the concerns about the issues of climate change resulted in highlighting the two fundamental response strategies, that is mitigations and adaptations by the UNFCCC, United Nations Framework Convention on Climate Change. So, the adaptation responses aim to alleviate the adverse impact through a wide range of system specific actions, and the mitigation process seeks to limit the emission of greenhouse gases and enhance sink opportunities, so that the climate does not change fast. So, looking at these adaptations and mitigations, if you see organic farming, the role of organic farming and the potential of organic farming as climate change mitigations. So, in general, sequestering carbon in the soil or the crop lands, grazing lands, range lands and other agriculturals have the highest potential for the climate change mitigations. So, if you can increase the carbon sequestration soil can be sink of the carbon dioxide. So, we can minimize the emission of greenhouse gases to atmosphere and so the climate change. That means, the carbon sequestration, lower input of fossil fuels dependent resources and use of renewable energy all present opportunities for organic agriculture to lead the way in reducing energy consumption and mitigating the negative effects of energy emission. Second, organic agriculture provides management practices that can help farmers adapt to climate change through strengthening agro ecosystems, diversity of crops and diversifying crops and livestock productions, and building farmers' knowledge base to best prevent and confront changes in climate change. So, we have discussed this also in detail in previous classes, as organic farming is an integrated farming system concepts, where we have the more number of crops, crop diversifications, and the livestock is an integral part of organic farming. So, in this integrated farming systems, so the output or the byproduct of one component that becomes the input of other components, that is a zero emission concept or you can say no emissions. So, there is no waste, all the on farm biological resources are utilized and it needs less off farm resources or less energy for this organic productions. That way it can have a less emissions or very greenhouse gases to the atmosphere, and that can you can say organic farming as a key for the for mitigating the climate change by reducing the greenhouse gas emission to the atmosphere. If you see the soil organic matter, the sequestration of soil organic matter, the climate change and the soil organic matter, you see there is a two schools of thoughts, whether with the changing temperature and the variable in precipitations, what will happen to soil organic matter, it may decrease or increase. One school of thought that says argues that climate change will cause soil erosion and degradations, especially in developing countries of tropics and subtropics. That means, so as we are discussing now with climate change, so there is increasing number of high precipitation events. So, because of high intensity precipitation events increasing, so that causes splitting of soil particles and erosion of the top soil layers, that means degradation of the soil, where top soils are fertile, top soils are rich in carbon. If there is a loss of top soil layers, erosion of soil through the water because of high intensity precipitation events, so that causes loss of soil quality and loss of soil organic matter. So, the soil erosion rate is controlled by erosive power of rainfall because of more extreme precipitation events under climate change scenarios. So, 1% increase in precipitation is expected to lead to 1.5 to 2% increase in erosion rates. So, so that is why the accelerated erosions will cause depletion of soil organic matter. Further, increased temperature and precipitation will accelerate this loss of soil organic matter, which is a great concern for low input agricultural systems. So, this is one school of thought. The other school of thought, this says that the second school of thought, you can say, that argues that CO2 fertilization effect with increased atmospheric CO2 concentration would increase biomass productivity with more litter and the crop residues returned into the soil and higher root mass and greater root exudations. So, because of the increasing root biomass and increasing the soil rhizosphere activity, so this should result in gradual increase in soil organic matter. So, this is a contradictory. One says there will be a decrease in soil organic matter, and the other school of thought there may be increase in soil organic matter in future climate. So, however, the net effect of climate change would depend on adaptive options or use of the recommended management practices. So, if you see the greenhouse gas emission from by different sectors, maximum being in energy supply sector, that is 25.9%. So, this includes your carbon dioxide, methane and nitrous oxide. And agricultural sector, the also we discussed last class, it contributes around 13.5% of the total greenhouse gas emissions. So, if you see the among the agricultural sector, the greenhouse gas emission maximum is from soil, that is around 38%, followed by enteric fermentations from the livestock, the ruminants, let us say 32%, followed by biomass burning around 12%, rice production contributes around 11% of the total greenhouse gas emission from the agricultural sector, and finally, the manures handling around 7%. So, these are the scenario of the greenhouse gas emissions from different sectors, and in agricultural sector from different components the greenhouse gas emission. So, if see the agricultural practice or the greenhouse gas emissions, the nitrous oxide emission, that is a high soluble nitrogen level in soil from synthetic nitrogen fertilizers. So, use of the through chemical fertilizers, and as we discussed the earlier class, because the yield management, improper management, unscientific management of this chemical fertilizers, especially nitrogenous fertilizers, that lead to emission of greenhouse gas nitrous oxide. And you can see from the figure, the red line shows nitrous oxide emissions in million tons of carbon dioxide equivalent after application of the fertilizers. So, that is increasing over the years as we progress, because there is increasing use of chemical fertilizers with increasing use. So, there is increasing emission of nitrous oxides to the atmosphere from these fertilizer applications. Moreover, when you are using fertilizer, because production of the fertilizer, black line shows energy used for fertilizer productions, this much of CO2 equivalent energy used for the fertilizer production. That means, there is increasing use of energy for the production of fertilizer, that also causes the global warming emission of the greenhouse gases to the atmosphere. So, this is the nitrous oxide emissions. Similarly, you can see the methane emissions. So, either the enteric fermentation from ruminants like cows, sheep and goats, then anaerobic turnover in rice paddies, because rice is grown under the flooded conditions, standing water. So, from the standing water rice field, so there is emission of the methane emission is higher as compared to the saturated conditions. And the manure handling, that also causes some methane emissions in the manure productions and the management. And biomass burning, that is a slash and burn agriculture, we have the zoom agriculture in that case, that emits both methane and nitrous oxides to the atmosphere. And if you see the carbon dioxide emissions, vegetations and together with the soil ecosystems as a place for decomposition, so generate large fluxes of carbon dioxide. According to IPCC, that is Intergovernmental Panel on Climate Change, this flux is nearly balanced agriculture, because the crop or the perennial trees, they also absorb carbon dioxide for photosynthesis. Though there is a release, they also absorb. So, in that case, this is the balance, the flux of CO2 from the vegetations is balanced in agriculture. Moreover, by sequestering carbon dioxide in soil, agriculture may contribute to the carbon cycle in a positive way. And the potential agricultural options you can see for minimizing the greenhouse gas options, greenhouse gas emissions, those are the improved cropland management. You have this scientific nutrient management that can minimize the greenhouse gas emission, this you have discussed in previous classes. Tillage and residue management, conservation tillage, minimum tillage and the incorporation of crop residue on the soil, that can minimize the emission of greenhouse gases to the atmosphere. Then water management as discussing. So, if you maintain the minimum water or the economic use of water, efficient use of water, that can minimize the emission of greenhouse gases. If you go for flooding like rice field, if you go for the flooded rice, that causes anaerobic decompositions and more release of methane from the rice field. Rice does not require standing water for higher productions. only saturation is enough to maintain a good level of productions, and under saturated conditions there will be less emission of methane as compared to flooded rice. So, that is a new rice production technology, that is a system of rice intensifications where no standing water is maintained, only saturations or field capacity saturation is maintained to have a better productions with less emission of greenhouse gases to the atmosphere. Then restoration of degraded soils, then agriculture can help to mitigate the climate change by reducing emission of greenhouse gases and at the same time by sequestering carbon dioxide from the atmosphere in soil, and for this the potential of organic farming for both means reducing emission of greenhouse gases and for sequestering carbon dioxide in soil is very high. See organic farming as climate change mitigations, because reducing the emission of nitrous oxide, inclusion of leguminous crops. By adding leguminous crops or by putting leguminous crops in a crop rotations, we can minimize, we can reduce the use of synthetic nitrogenous fertilizers. So, for this the information, the potential nitrogen production by leguminous plant via intercropping and off season cropping to be 154 million tons, a potential which exceeds the nitrogen production from fossil fuel by far and which is not fully exploited by conventional farming technique. So, there is a great scope, great opportunity, we can include leguminous crops in the crop rotations or the cropping system, so that we can minimize the use of synthetic nitrogenous fertilizers. Then diversified crop rotation with the green manure crops, then organic managed soils are the aerated, higher aerated as compared to the conventional fertilizer managements or the chemical fertilizer, and because of the more aerations they have the significantly lower mobile nitrogen. Then also reducing methane emissions, we discussed avoid continuous flooding, there should be only saturation in the rice field. We do not need to flooding water to have a higher productions. Saturations, well managed water can give a good production, high productions with less emission of greenhouse gases to the atmosphere, and also the variety, also there are some varieties we can have a less emitting of the greenhouse gases. So, reducing carbon dioxide emissions, so different options we can use for how you can minimize the emission of carbon dioxide. Organic farming, as we discussed, the way of reducing the CO2 emissions, and conservation tillage, agroforestry. So, this the table shows how the tillage practices that can minimize the emission of greenhouse gases. If you see the compare the conventional tillage versus conservation tillage, kg carbon equivalent per hectare per years, and these are the global warming potential components. So, soil carbon sequestration for the conventional tillage, if you reference as a 0, in conservation that is minus 337 kg carbon per hectare per year, means this much carbon is lost to the atmosphere through conventional tillage, and if you go for the conservations, this carbon is protected in the soil, that is restored in the soil, that is sequestered in the soils if you go for the conservation tillage. That is for the soil carbon sequestration, and if you go for the CO2 emissions through agricultural inputs. So, this is the carbon emission is higher in case of the conservation tillage as compared to conventional tillage. In conservation it is around 202 kg per hectare per year, in conventional 156 kg carbon per hectare per year. This is because in agricultural inputs application in conservation tillage are high, especially for the fertilizers that is not well managed, may be sprayed on the surface soil, that causes more emission of nitrous oxide. And also if you go for the conservation tillage or the less tillage, we go for the more application of the herbicides to control the weed in conservation tillage. So, in that way there is more emission of the greenhouse gases to the atmosphere. And if you look at the machinery in case of the higher emissions only conventional tillage, because more use of the farm machinery in conventional tillage. So, if you see the net flux in case of the conventional tillage plus 228 kg carbon per hectare per year, if you go for the conservation tillage it is minus 112, and if you see the relative carbon flux looking at the 228 plus 112, that means 340 kg carbon equivalent per hectare per year, that is sequestered in the soil in conservation tillage as compared to the conventional tillage. So, that is what the tillage practices also one of the options, and organic farming we have discussed also, we go for the conservation tillage or this double mulch tillage, so that it can minimize the emission of greenhouse gases to the atmosphere. And if you give example how organic farming as a global warming, reducing global warming potentials, the relative global warming potential of organic agriculture compared to conventional agriculture. So, world levels in European countries they have studied at the farm levels, at the experimental levels and also product levels. If you see the reduction in greenhouse gas emissions, so that is most of the cases, so there is a decreasing greenhouse gas emission or there is reduction in greenhouse gas emissions in organic farming as compared to conventional farming. So, if you see here for the farm levels, the two farms there is 18% reduction in greenhouse gas emissions. Similar experimental levels, in farm levels here the two farms shows there is a increasing emission of greenhouse gases. One farm shows plus 2%, the other farm shows plus 53% emission of greenhouse gases to the atmosphere, but in crop level you can see the many crops that shows there is a decreasing emission of greenhouse gases to the atmosphere in organic farming as compared to conventional farming. If you take the example of those farms where there is a higher emission of greenhouse gases to the atmosphere in organic farming, suppose these two farms will take example, in one case 2%, the other case 53%. So, this is without considering carbon sequestration. That means, the amount of organic matter added to the soil that is not considered. All the cases is not considered the carbon sequestration. For those farms, if you see the carbon sequestration in the soil, in this case again the emission becomes negative. If you see the right hand side this graph, for those farms the suppose 53% higher emission of greenhouse gas at atmosphere in organic farming as compared to chemical farming, carbon sequestration is not considered. That means, amount of organic matter added to soil in organic farming that is not taken into account. If you take those into account, then it becomes negative minus 80%. That means, while considering carbon sequestration, the organic farming system that makes a huge reduction in greenhouse gas emission to the atmosphere as compared to chemical farming. Same in case of the other farm. In this case, if there is 2% increase in greenhouse gas emissions if you do not consider the carbon sequestration, but if you consider the carbon sequestration, there is 26% reduction in emission of greenhouse gases. So, we have got from our Indian experiment, from our group also we have seen the global warming potential of organic nutrient management in rice. We have seen here we have different nutrient management treatments. We have the control means no fertilizer is used, and CF100 where using chemical fertilizer at the 100% recommendation. BC100 means we are using vermicompost at 100% N recommendation, and CF50 BC50 means the chemical fertilizer at 50% and vermicompost at 50%. BC B100 is the vermicompost 100%, but the whole vermicompost applied at the time of sowing of the crop, and this BC100 is the vermicompost whole is splitted in two doses, one at the time of sowing, the other at time of panicle initiations. And the other treatment is crop residue, nothing is added except crop residue of the previous crop, and this treatment is chemical fertilizer 50% with crop residue, here vermicompost 50% crop residue, here vermicompost and also vermi bed wash. So, with these treatments we wanted to know what the carbon dioxide emission from the soil, that is kg carbon dioxide equivalent per hectare per crop cycle of around 5 months. So, if you see the different treatments, here chemical fertilizer shows huge emission as compared to other organic fertilizers. So, the emission from chemical fertilizer in around 5 to 6 months around 3500 kg carbon dioxide equivalent per hectare. But you see the vermicompost, the emission is around 2000 kg carbon dioxide equivalent per hectare. And also we calculated the kg carbon dioxide released per kg of rice grain. The bottom figure if you see this one, the kg CO2 released per kg of rice grain. In this case also chemical fertilizer shows higher, that is 0.8 kg, around 0.8 kg carbon dioxide released per 1 kg of rice production. But if you see the vermicompost at the same time, it shows 0.4 or maximum 0.4 to 0.5 kg carbon dioxide released per 1 kg of rice production in case of the organic treated plots, and at the same time we are using 0.8 kg of carbon dioxide per 1 kg of rice production in case of the chemical fertilizer plot. And also we compare this one assessment of nutrient management as compared to chemical fertilizer for different treatments in comparing the chemical fertilizer as a normal, usually farmers use chemical fertilizer. If you compare different organic treatments, so there is a yield loss. If you see, if you apply vermicompost at 100% N equivalent basis, the yield loss is 9% as compared to chemical fertilizer. However, the global warming potential reduction is around 41%, though there is a 9% yield loss. So, we reduce the greenhouse gas emissions. So, we reduce the global warming potential 41% using organic nutrients. And if you go for the integrations, organic and chemical together, in this case the yield loss is 4% and the global warming potential reduction is around 30%. So, either when you go for the management practices, especially for rice crop, either you have to advise for the full vermicompost or integrated nutrient management. So, that yield loss is 4 to 9% and there is a substantial reduction in the global warming potential. In case of the other treatments, so there is a huge yield loss with 15% or higher. We do not want to go for the other treatments as there is yield loss is more than 15%. When between the BC or the vermicompost 100% or the integrations. So, for my advice we can go for the integrations, because it will be to meet the vermicompost 100% you require around 6 tons of vermicompost per hectare. In this case we need 3 tons. So, depending upon the resource, if the resource is limited we can go for the integrated nutrient management, so that you can have the same yield as of the chemical fertilizers and there is a around 30% reduction in global warming potential. So, other way organic farming as climate change mitigation. So, changing consumer behavior and diet, production of meat require inputs that are 7 times as high as the inputs needed to produce same quantity of non-meat calories. That means, the greenhouse gas emission is highest in beef production, that is around 10 kg per kg of the beef, 10,000 gram of greenhouse gas is emitted per 1 kg of beef production, followed by pork, poultry and egg, that is around 2 to 3 kg of CO2 equivalent per kg and followed by milk, exactly 1 kg carbon dioxide per 1 kg of milk productions. But if for the vegetables, emission from the plant foods generally below 500 gram carbon dioxide equivalent per kg of the plant based products. So, in this case you can see, so plant based products they do emit less carbon dioxide, and whereas the beefs or this the meat based products they do produce the huge amount of greenhouse gas emissions to the atmosphere. So, the other one is the organic agriculture aims at precisely this goal, consumption of less processed products and increased consumption of products like cereals, potatoes, pulses and oils. That means, if you are consuming more of the processed products, in that way there is a more we are contributing the emission of greenhouse gases. Fresh products are better from the organic point of view. Then finally, stop deforestations, so that you can minimize greenhouse gas emissions. So, in the final slide, the performance of organic farming as compared to conventional farming in context of climate change. So, wherever there is a negative sign, that is slightly inferior. So, that is the yield level or the productivity. As we consider the production or the productivity, the organic farming slightly inferior. So, there are the two positive, there are the single positive, the slightly better, that means global warming potential of productions organic farming is better, and further potential for improving the systems to climate change organic farming is better. So, the plus the signal, the symbol of plus and plus 2 plus, they are clearly better, that means the adaptiveness to climate change organic farming is clearly better, and also carbon sequestration in the soil carbon, in the increasing the soil carbon stock organic farming is a better options, and definitely better there is a soil erosion and degradation. So, through organic farming we can minimize soil erosions and degradations, also various ecological impact, ecological diversity, nature conservations, water use efficiency and environments. So, that can be protected through organic farming, that is definitely better. That means, in brief, so to say organic farming, as there is a climate change is certain. there is a rising in temperature, there is a decreasing water availability for agricultural productions and that increasing carbon dioxide concentration. And in view of that, we have in these environments, in these adverse conditions, we have to go on increasing productions. At the same time, we have to see a better quality productions. At the same time, we have to see a better environment. For this, organic farming has a key role, is a key candidate we can say for mitigating the climate change or for a better adapting to climate change, because organic farming that can minimize the water consumptions. At the same time, it can adapt well to climate change conditions, and through organic farming we can minimize the greenhouse gas emission to atmospheres, we can maintain a better environments, we can have a good food productions with a better quality. Okay. Thank you.